We will discuss another problem on projectile motion and horizontal plane in this class. So the problem runs like this. A projectile is fired with a velocity of 300 meters per second at an upward angle of 60 degrees to horizontal. Neglecting air resistance, find the time of flight, range, its position after 35 seconds, its velocity after 35 seconds. See here, in this example, he has given that a projectile is projected on a horizontal plane. Unless it is specified, you consider the plane as horizontal plane, so that this is x-axis, y-axis, A becomes the origin, point of projection becomes the origin. Now the projectile will be traveling in the form of a parabolic trajectory like this. C is the maximum height that is going to reach, and R is the range. If I take this as B, AB is the range, and the time of flight is nothing but it is the time taken by the projectile to travel from A to B. So that is time of flight. So time of flight I am going to take as P, range is R, then its position after 35 seconds means, so it may be somewhere here after 35 seconds, let us say it is at this point P. So position means I need to find this x and y, coordinates of this point P after 35 seconds, at t is equal to 35 seconds. The x and y we have to find out, that is the position. Then its velocity after 35 seconds. So here it will be traveling with some velocity like this. With velocity, resultant velocity of course. So the resultant velocity we have to find out. Of course, this resultant velocity will be comprising of both horizontal and vertical components. We have to take the resultant. So this is the given problem here. Now let us write down the data whatever is given. The projectile is fired with a velocity of 300 meters per second means, so the velocity here at the point of projection, u is given here. So u is equal to 300 meters per second. Then angle is given, angle of projection alpha 60 degrees. So this is the angle of projection, that also has been given as 60 degrees to the horizontal. Neglecting air resistance means there is no other force acting on the projectile. Suppose if some resistance is there from the air, so what happens, its velocity gets reduced, because when the projectile is traveling like this, resistance means the air will be acting in the opposite direction. So naturally velocity will be reduced, but we are neglecting the air resistance, so that the horizontal component of the velocity, remains same throughout the flight, so which is u cos alpha. So horizontal component of velocity, you know that it is u cos alpha, which is given, it is nothing but 300 into cos 60, which is 150 meter per second. So this is the horizontal component, it remains constant. Please note that horizontal component of velocity remains constant throughout, whereas the vertical component will change. So this is constant. So vertical component of velocity is will go on changing, because it will be under acceleration due to gravity. Now, since you know these two are given, we can directly find out the time of flight and the range using the formula. So time of flight, of course, you know that it is given by, time of flight is given by the formula t is equal to 2u sin alpha by g. So first thing, you should remember the formula, time of flight, that is to travel from A to B. So it includes both upward motion as well as the downward motion. So time of flight is denoted by t. So this t is given by 2u sin alpha by g. That we have proved already. 2u sin alpha by g. Let's substitute the values now. 2 into 300 into sin 60 degrees divided by 9.81. So this comes out to be in seconds. So this will be in seconds. So let us see what is the value. 600 into sin 60 divided by 9.81. 600 into sin 60 divided by 9.81. The answer is 52.97. 52.97 is the time of flight to travel from A to B. Next, second we have asked the range, that is the horizontal distance traveled by the projectile, that is distance, horizontal distance from A to B. So that range is given by R. So once again we have to use the formula for R, U square sin 2 alpha by G. So by knowing alpha and the U, you can easily find out the range as well as time of flight. So that is U square is 300 square into sin 2 alpha means alpha is 60 degree, sin 2 alpha 120 degree divided by 9.81. So you will be getting the range in meters. So 300 square into sin 120 divided by 9.81. So you will be getting 7,945. So 7,945.19. 7,945.19 meters. So that means almost it is 7.94 kilometers. Okay. So maybe it's a bomb, something like that. So that is the range you are going to get in meters. Now the third thing is its position after 35 seconds means we have to find out x and y. So I have shown the diagram. Let us see. Let us say that the projectile has come to the point P after 35 seconds. So t is equal to 35 seconds. What is the position of the projectile means x and y we have to find out. So x is found out using the horizontal motion equation. Y is found out using the trajectory motion equation. So the horizontal motion equation is x is the distance traveled is equal to u cos alpha with the horizontal component into time. So velocity into time is the distance. So this is the equation. So u cos alpha, as you know, it is 150 horizontal velocity into 35. Time is 35 seconds as given. So 150 into 35 comes out to be 5,250 meters. So 5,250 meters it has traveled horizontally after 35 seconds. Next, we have to find out the vertical distance also. So to get the position, so vertical distance is obtained by the trajectory equation, which is a parabola. Trajectory equation, which is a parabola. So the equation given here is y is equal to x tan alpha. This we have derived. Equation of trajectory, y is equal to x tan alpha minus gx square divided by 2u square. Minus gx square divided by 2u square into, of course, cos square alpha. You can write either like this, or you can bring that cos square alpha to the numerator, becomes secant square alpha, that is 1 plus tan square alpha. Now here x value is known, 5,250 meters, alpha is 60 degrees, g 9.81, then u value 300 meter per second. Now substitute those values, you get the y value. So substituting the values, so you will get y is equal to y coordinate, that is the ordinate, x is 5,250 into tan 60 degrees, alpha is 60 degrees, minus g is 9.81 into x square 5,250 square divided by 2 times 300 square into cos square 60 degrees. So this is the equation you are going to get. Now if you simplify this, you get the value of y in meters. So let us see what is the value of y you are going to get. So simplify it carefully using the calculator. First I will do this. 9.81 into 5250 square divided by 2 divided by 300 square, that is 9 followed by 4 zeros, divided by cos square 60. So you are going to get this value now. So then minus of that plus this. So it becomes now, I will tell, 5250 multiplied by tan 60. So you will be getting the answer as 3084.64, correct, 3084.64. So we have to carefully substitute and simplify. So this is the vertical distance traveled by the projectile at the time t is equal to 35 seconds. Now we have found out the position now. So position of the projectile, after 35 seconds is equal to, I can write in terms of coordinates, 5250 meters, 3084.64 meters. X and Y meters. Next, coming to the last part of the problem, we have to find out its velocity after 35 seconds. That means at the point P, whatever velocity is there, that we have to find out. So you know that at this point P, so it is traveling like this. If you draw a tangent to this trajectory, so that is the velocity here. But this velocity is nothing but the resultant of horizontal as well as vertical velocity at this point. So like this. So very careful. So at this angle I can take it as theta. So when you are asked to find velocity, you need to find both magnitude and direction. Magnitude, of course, this is your VH, horizontal component. This is your vertical component VV. So this resultant velocity V at this point P is given by square root of VH square plus VV square. So horizontal and vertical. So you know that the horizontal component velocity remains constant throughout the time of flight. So VH is constant here. So 150 meters per second. That is the horizontal component of the velocity. Whereas vertical component you have to get because it has traveled. So this is the point C here. See, please observe here. This point P lies after C because the total time of flight is 52.97 seconds, and at P it is 35 seconds. That means half of 52.97 seconds is required to travel from here to here, which is nothing but some 26 point something. Since this is 35 seconds, it has crossed point C, it has crossed the maximum height point. So therefore I have taken here. Now I have to consider the motion of the projectile along the tangential direction. So the equation which I have to use here is vertical component VV is given by so u sin alpha minus dt. So this is the equation. U sin alpha minus dt is the equation. Now here, so what happens? U is 300 into sin 60 degrees, alpha is 60 degrees, minus 9.81 into 35. So this is the velocity, vertical component of velocity after 35 seconds. That's why I told you, this vertical component of velocity varies with time. It is not constant. Whereas horizontal velocity is not a constant. It is not a variable. It is a constant. So throughout from A to B, horizontal velocity is u cos alpha only, whereas vertical component of velocity keeps on changing. That's why your resultant velocity also keeps on changing. Now you substitute the value now. 300 into sin 60 minus 9.81 into 35 because we need 35 seconds. So it is minus 83.54. Minus 83.54 seconds, meters per second. This minus indicates that it is downwards. That's all. So forget about the direction. Only magnitude is important. So I have shown the direction here. Now you know these two values, VH and VV. velocity at p, that is after at 35 seconds. So it is v, which is root of vh square plus vv square. So we are going to get it as root of 150 square plus 83.54 square under root. So that is what I will get is 150 square plus 83.54 square under root. So you will be getting 171.69 or 171.69 meter per second. This is the resultant velocity, that is this value. And if you want to find the inclination of that, so theta, so you know that it is tan inverse of Vv by Vh modulus. So which you are going to get it as Vv is 83.54 divided by Vh is 150. So tan inverse of that you will be getting 29.1 degree. So the angle made by the velocity after 35 seconds or at point P is 29.1 degree. So these two we have found out. This is the fourth part. So like this, they may give some data, they may ask you to find some other parameters. So only thing is, here in this problem, I have directly used these two formulae for time of flight as well as range, because we know these two. So better we have to remember the formula directly can use. Then I have used the equation of trajectory to find y and the horizontal motion equation to find x. Later on, resultant velocity at any point if they ask, so it is nothing but square root of horizontal component square plus vertical component square. Horizontal component of velocity remains same throughout the flight, whereas vertical component keeps on changing, it depends on the value of t.